Hi, this is your lucky sir. We are discussing ionic equilibrium. Fundamental questions, conceptual questions, basic level questions about ionic equilibrium. This is worksheet 11. So 124 questions are there in our earlier videos. You can check those. Okay. Now we are with buffers. A buffer solution contains a weak acid Ha and A minus. This is a salt. When small quantity of NaOH is added to keep the pH constant, which of the following reaction takes place? This comes in our working of buffer. When you are adding base, weak acid will react. So Ha will react with base to form H2O and A minus, which is already with us. So this is your right answer. Fine. 1m NaCl and 1m HCl are present in an aqueous solution. The solution is All India Engineering Entrance Examinations. Very simple. NaCl is neutral, so no worries about this. Just look at this HCl. HCl is acidic, so it is not a buffer solution because buffer solutions are made from weak acids. This is HCl, so it is strong. Only acidic solution pH is less than 7. Okay, so these options however wrong because buffer is mentioned here. It cannot be more than 7 because HCl is strong acid. Which of the following pair of solutions does not form a buffer solution? This is very interesting question. Actually, what happens here is you need to be very careful about what combination is given. See here, NaH2PO4, Na2HPO4, whether it functions or not. See, NaH2PO4 can still release one proton. So this is acid, and you can say it is its salt, weak acid, and a salt with its strong base. But if you see this one, it's a combination of strong base and its salt with strong acid. So this combination won't work out. So this is your answer. Does not. From the following table, buffer solution, volume of 0.1 m weak acid, volume of sodium salt. Okay, what he is asking is the values are somewhere they have gone. Okay, this third one should be here. What we need to check is which of the two sets of buffer solutions have least pH. pH is equal to minus of log H plus, this is for normal acids. Here pH is equal to pKa plus log of salt by acid. So what is asking? Least pH means acid concentration should be more and salt concentration should be less. Acid concentration more and salt concentration less. See, acid concentration, both are same here. Here salt concentration is more, so this is not your option. You cannot go with this. Here 0.1 and 10, and this is fourth option. Again this is more, so this is again we cannot use this one. Here this is more. This is acid, this is salt. When acid concentration is more, salt concentration is less, your choice works out. Least pH 1 and 3. Few drops of HCl is added to acidic buffer. The pH is maintained constant by. As we were discussing, HCl, and when you are adding acidic buffer is CH3COOH plus CH3COO minus ions. These acetate ions are going to react. Okay, acetate ions will react with HCl and they form CH3COOH. Working of acidic buffer. See one big question you can see here. A physician wishes to prepare a buffer solution of pH is equals to 3.58. That efficiently resists a change in pH and blah blah blah. Which one of these following? So question is asking the pH 3.58. You should get Okay, 3.58 is equals to pH is equal to pKa. pKa is given 3.98 plus log of salt by acid. So in which case it is going to be possible. Okay, so which of the following weak acid together with sodium salt would be best to use is asked. Best to use means pH is equals to pKa. That is best. Here pH is given 3.58, so which pKa is given. So this is best. Best I am saying. All these can be used, but the best is pH is equals to pKa. Correct? Which one of the following mixture acts as buffer solution? This is again one interesting one. See, weak should be always greater. CH3COH, NaOH, this is strong base. So weak acid should be greater in quantity. Concentration is more. Volumes are same here. Don't worry about the volumes. Just look at the concentration. This is more than this. So this definitely works. What is the problem here? This strong base is more, so this won't work. What is the problem here? This can also function. This can also function. Is okay, not a bad one. Okay, now. But best option is this one. When this option is given, you can comfortably go with this one. Weak acid must be greater than strong base. When weak acid is almost equal to strong base, it is also a buffer, but a worst buffer you can say. It's a buffer. Just buffer बुलाया जा सकता है इसको. ये कुछ ज़्यादा काम का नहीं होगा. Few questions about hydrolysis of salts. Aqueous solution of salt of strong acid and weak base. Acid is strong, weak is base. Okay, base is weak. So what acid you can take, what base you can take, NH4Cl. From this NH4 part is undergoing the hydrolysis, NH4 plus. It undergoes hydrolysis to form NH4OH and H plus. So when it is strong acid, it is acidic in nature. It undergoes this NH4 plus hydrolysis, cationic hydrolysis. pH is definitely less than 7. So all of these correct. Coming to the next one. A salt of weak acid and a weak base undergoes both cationic hydrolysis and anionic hydrolysis, because weak acid is there because of this and weak base is there because of this. It undergoes both hydrolysis. The compound whose 0.1 m solution is basic is, okay, now basic is mentioning, so here strong base should be used. Strong base is used in this case. Weak acid, strong base combination. In all these cases, ammonium we are using, ammonium is weak base. Which of the following salts does not undergo hydrolysis? Very, very simple. Does not undergo hydrolysis is a combination of strong acid, strong base. Strong acid, strong base salts never undergo hydrolysis. The nature of aqueous solution of copper sulfate is, copper is weak, sulfate is strong. So this is coming from actually from sulfuric acid. Anionic hydrolysis. Anionic hydrolysis is acidic in nature. Aqueous solution of which of the following shows lower pH? Lower pH means strong acid should be there. Strong acid means you can go with this chlorine. This is best option. It is pH 7, neutral. KCN, potassium strong, above 7. This is almost equal to 7. Both are weak. The hydrolysis constant of CH3COONA is given by, it is weak. It's a weak acid, strong base salt. When it is weak acid, strong base salt, hydrolysis constant KH is equal to KW by KA. Weak is there, na? So Ka. If it is weak base, Kb. If both are weak, Kw by Ka into Kb. Which of the following salts undergoes anionic hydrolysis? Anionic hydrolysis is a property of weak acids and strong bases. Which of the following shows relatively higher pH? Higher pH means stronger base should be there. KOH is stronger base. Aqueous solution of salt of weak acid and strong base. Okay, weak acid, strong base. Strong base means pH will be more than 7. Correct. OH plus concentration is more than H plus. Basic is nature. So all correct. MX is the salt of weak base. MOH is the weak acid. Aqueous solution of MX is, okay now, it depends. Okay now, this is very very important. If Ka value and Kb values are same, then you can say that is neutral in nature. If Ka is greater than Kb, then that will become acidic. If Kb is greater than Ka, that will become basic. So here right option is only neutral. The pH of an aqueous solution of a salt is 10. The salt is, obviously, you can see the strong base salt. Strong base salt is CH3CONA. It is pH 7 neutral. So we'll discuss few more questions in coming up videos. Thank you. Doubts you can post me. No calling. I am not available on this number, but WhatsApp purpose you can use this number 8904467423. Signing off, Lakshman Reddy sir. If you like this video, please do subscribe, share with your friends. Thank you.